question is, there is a body of mass 1 kg. It is tied to a string of length 10 meter, and this, the other end, is nailed over here. It is fixed. This body is released from here. When you release the body, this will oscillate like this will move like this. We have to find what is the tension in the string when it reaches the bottom, right? When it reaches the bottommost position, we have to find the tension in the string. So we know that is over here, this is circular motion. If this is circular motion, first of all, we find out whether this is uniform circular motion or non-uniform circular motion. As it is coming down, obviously you will find that its speed is increasing. That is, there is a change of speed. If there is change of speed, you know this is non-uniform circular motion. So this is non-uniform circular motion. In non-uniform circular motion, there are two things. One is centripetal acceleration, the other is tangential acceleration. Over here, we are interested primarily at this point when the body reaches over here, we are interested in the tension only. So what I do is, I draw a circle over here. I see what are the forces which are acting on this. mg is acting this direction. P is in this direction. It's okay. We have done, that is, whenever a body of mass m wishes to move in a circle of radius r with a velocity v, there is a net acceleration. Net acceleration towards the center, it is AC is equal to v square upon r. And we also know that is net force is equal to mass into acceleration for constant mass bodies. So if I put the value over here instead of A, so the centripetal force comes out to be, instead of A, I put v square upon r, mv square upon r, that is centripetal force. So whenever a body of mass m wishes to move in a circle of radius r with a velocity v, there has to be net force mv square upon r towards its center. It has to be there. And who will apply these forces? There will be some forces. And the resultant will be, that is, net is going to be mv square upon r towards center. Over here, I observe two forces. One is tension. You know that is when you draw a force diagram or free body diagram, tension is away from the free body, so tension is in this direction. Mg is in this direction. So there are two forces. P is this way towards center, mg is away from the center. Net force we have to do towards the center. Net force should be centripetal force, that should be towards center. And its value should be mv square upon r. So these two forces, they will result into mv square upon r towards center. So net is P minus mg, that is net force towards center, and that should be equal to what? That should be equal to mv square upon r, right? Over here, one point to be noted is, when I ask the students, that is how many forces they're acting at this, in this equation, they say one is T, the other is mg, the other is centripetal force. So there are three forces. No, they are not three forces, there are only two forces. One is tension, the other is mg. These two forces, they are meeting the requirement of the centripetal force, right? Like, if I say there is a block, IF is here, I apply here, and mass is of this, and as a result, it has an acceleration A. Then what is the force? You will say F is equal to ma. You don't say that there are two forces, one is F, the other is ma. They are not two forces. There is a single force, F, whose value is equal to mass into acceleration. Similarly, this is a net force, whose value is m into v square upon r is the acceleration. So net force equal to mass into acceleration, what we do in the Newton's second law of motion. When the body is moving in a circle, generally there is a velocity. You cannot, obviously, you cannot use the equation of kinematics, v is equal to u plus at s is equal to ut plus half at square, or v square minus u square is equal to 2as. You know very well that these equations of kinematics, they are applicable only if a is constant. When it is coming down, it is not coming with the same acceleration. Acceleration is not same, right? It is changing. So these equations directly you cannot apply over here. So what we do is, we use the energy conservation methods to find the velocity over here. Because if we have to find P, mg is known. So velocity is one of the other constraints which if we know, then the whole thing is done. So how to find V? That is, when we consider between A and B, right? When we consider between A and B, there is a conservation of mechanical energy between points A and B. That is, mechanical energy at A is equal to mechanical energy at B. There is no loss of any energy, be it potential, be it kinetic. There are no dissipative forces, friction, etc. is not there. So the total mechanical energy over here is equal to total mechanical energy over here. For that, for convenience, let me take a reference level over here, I take a reference level. This is reference level because for reference level may be required when we are going to find out what is the potential energy of this body, right? Which we'll do later on, let's say in detail, how we solve such questions when we have to find the velocity, etc., using the work, power, and energy principles. But right now over here, the basic things we do is, I just take this reference level. So mechanical energy over here of the body should be mechanical energy over here of the body. So mechanical energy is what? Gravitational potential energy at A plus kinetic energy at A should be equal to potential energy at B plus kinetic energy at B. Potential energy at A, this point. This is the reference level over here. So if this is 10 meter, so this is also 10 meter. Obviously this is 10 meter. Length of the string is 10 meter when it comes over here. So this is also 10 meter. So if this is 10 meter, so this height is also 10 meter from this reference level. So the body has a mass m. So it is, I say, though even m is also given, mg, I say 10 mgh plus over here the velocity is 0. Kinetic energy, you know, that is half mv square, half m0 square, or I say 0 only, is equal to potential energy at B. This is the level. The body is at 0 height from this level. So it is mg0 plus over here I say the body suppose is moving with velocity v. So it is half mv square, where v is the velocity of the body at this instant. So over here I observe that is this and this, they go m, and so from here mg10 is equal to half mv square, m and m they go, so it is 2g10 is equal to v square. What we require over here, v square is required, so v square is 2g10. So over here T minus mg is going to be m into g is 2g10 upon r. R is obviously once again 10 only. This goes. So this way, when we have questions like this at the, but this is, remember, this is at the lowermost position. Someone asks over here, let's say someone asks over here, what is the tension right now when the string is making an angle, suppose angle theta with the horizontal string, then please don't use it. This is the most simplified case I have taken. Now let's understand if this angle is theta with the horizontal or with this string, then how to go about these type of questions. Now the question is, there is a body of mass m which is tied with a string of radius r or length r. It is nailed over here so that it oscillates or it moves like this. When this reaches position B, that is, this string is making angle theta with the horizontal, then what is the tension in the string? Suppose this is the question. Now how to deal with these questions? Over here, I observe when it reaches over here, this is mg is always acting downwards, right? The other is when the body is coming down, its speed is changing. So this is a non-uniform circular motion because speed is continuously increasing. When speed is continuously increasing, so obviously the speed is not constant. So this is non-uniform circular motion, right? And if this is non-uniform circular motion, so we shall be obviously interested in the centripetal acceleration also. For centripetal acceleration is equal to v square upon r. So we require the value of speed over here. How to find the speed? In vertical circles, when the bodies are moving in vertical circles, these speeds over here, they can be found out generally using the principles of conservation of mechanical energy. That is, what's the mechanical energy over here, the same mechanical energy will be over here, right? If this is a single block body, then what you can say is that is loss of potential energy equal to gain of kinetic energy. Something like this, you can use it. Remember, this is only for the single block systems. If there are multiple block systems, then you cannot say that is loss of potential energy is equal to gain of kinetic energy. It is only for the single block system, because the total mechanical energy of a body is, that is potential energy, gravitational potential energy plus kinetic energy. That is, mechanical energy is gravitational potential energy plus kinetic energy. If the dissipative force, if they are not there, friction etc. is not there, so this is constant. So sum of potential energy and kinetic energy is constant. If one will increase, the other will decrease by the same value, provided this is only for a single block system. So when it comes from here to here, it is coming down, it is going down. So there will be loss of potential energy, and there is going to be the same gain of kinetic energy. So loss of potential energy from here to here is equal to gain of kinetic energy. Now let's see, if this is R, if I draw this as a rectangle, this is R, so from here to here, in this right angle triangle, this is from here to here is R cos theta, this is R cos theta. In this right angle triangle, R cos theta, this is hypotenuse, this is one side, the other side, angle is 90 degree. So this is R cos theta, and this is R sin theta. So this has come down by the value R sin theta. It has come from here to here. How much it has come down? It has come down by the value R sin theta. So this is R sin theta. And this is R cos theta in this right angle triangle, right? So it has come from here to here. So loss of potential energy is equal to gain of kinetic energy. It is gain of kinetic energy. What is loss of potential energy? It is mg, loss of height. Loss of height is what? mgr sin theta is equal to what? Half mv square. M and M, they are cancelled. So v square, the value of v square is going to be 2g r sin theta. That is value of v square. Now let's consider forces. Now one is mg this way, the tension, as we know, that is always toward the center, that is away from the body, away from this body we are talking about. So now the problem comes, that is whether we should resolve tension into two forces or mg into two forces. This force mg will be resolved or tension force will be resolved. Whenever you are in a situation like this, remember that do not disturb the forces which are along the radius of the circle in which the body is moving. Do not disturb the forces which are aligned along the radius of the circle in which the body is moving. The body is moving in this circle. This tension is along the radius. So do not disturb it. This will remain like this. So the other forces, they will get broken. How they will get broken is, that is, break these forces in such a manner that is one force is along the radius. That is, one is, I break this like this, I can break it like this. So this is mg, I break one this component, the other is this component. Now if I to see, that is which way will be the angles. Now we can find out the angles also. This is theta, this and this, they are parallel. This line is cutting it. So if this is theta, by simple mathematics, we know this is theta. If this is theta, vertically opposite angle, so this is theta. If this is theta, so this is 90 minus theta. If this is 90 minus theta, this total angle is 90. So if this is 90 minus theta, so this is theta. So if this is mg, this angle is theta, so this component over here, this is going to be mg cos theta, and this component is going to be mg sin theta. It's okay. We have resolved this force mg into two parts. One is mg sin theta, the other is mg cos theta. Whenever you have a confusion, let's say at this point, what will the angle theta? So you draw x and y axis, and then you can use the basic rules of geometry. That is, this is theta, these two lines transverse, theta, theta, vertically opposite angle theta, this and this is 90 degree. So if this is theta, this is 90 minus theta. This angle and this angle, we have broken this into rectangular components. So the angle between the two, it has to be 90 degree. So this angle plus this angle has to be 90 degree. If this is 90 minus theta, then it has to be theta. You add the two, you get the angle total as 90 only. So this is theta. So this is mg. This component is going to be mg cos theta. This component is going to be mg sin theta, right? So over here, I observe that is what are the forces which are acting along the radius. Along the radius, there are two forces acting. One is P this way, the other is mg sin theta this way. Is the body moving in a circle? Yes, the body is moving in a circle. If the body is moving in a circle, does it have a centripetal action? Yes, it has a centripetal action, being v square upon r. If it is moving in a circle, does it have a net centripetal force? Yes, it has a there has to be a central force, net force this way. And so when the net force has to be this way, I find P is this way, mg sin theta is away from this. So P minus mg sin theta, these two, they should be equal to mv square upon r, that the net force should be equal to mv square upon r, that is the centripetal force. P is acting this way, mg sine theta is acting is this way, net force has to be towards center because of these two and its value should be mv square upon r. So P minus mg sine theta is equal to mv square upon r, right? Over here, that is, you can find the value of P, right? And what is this force? This is tangential force, F tangential. So tangential force in this case, tangential force is equal to mg cos theta. Tangential force is obviously equal to mass into accretion tangential. So accretion tangential is going to be equal to g cos theta. In the examination, the value of theta, etc. will be given. So it has a, because it is coming over here, the speed is continuously changing. So this is non-uniform circular motion. If this is non-uniform circular motion, it will have two accelerations. One is centripetal acceleration, the other is tangential acceleration. If tangential acceleration is there, there has to be tangential force. What is the tangential force? This is the tangential force. So what is the tangential acceleration? Mg cos theta is equal to ma tangential. A tangential is what? V cos theta. So tangential acceleration over here is g cos theta. And what is the centripetal acceleration this way? It is going to be v square upon r. You can find the values. V, you have found the value. V square upon r if you do it. So it is 2g sine r sine theta divided by r. So it is going to be 2g sine theta. So centripetal acceleration this way is 2g sine theta. This way is v cos theta is the initial acceleration. And resultant of these two, as we have done in the earlier example, you can find the net acceleration as under root of ac square plus at square, and you can find the value, right? So over here, but don't cram it, that is, this is going to be always mg sine theta, this is going to be mg cos theta. See if the angle is theta is given like this or this. In many lecture books or questions, theta may be this, theta may be this. So depending on which theta is given, you will resolve this into mg cos component and mg sine component. Now we do conical pendulum. In conical pendulum, this is a rod, and over here there is a body of mass m, and it is being revolved like this. So it is revolving around this, like in this horizontal circle. This is revolving in a horizontal circle. We have to find what is the angle theta and all those things. Let's understand the basics, that is what are the forces, etc., which will be acting on this. Suppose this angle is theta, this is L, and this is moving in a circle, this circle. So you can say that is in this right angle triangle, if this is L, so this is L cos theta from here to here, and R is going to be L sin theta. This okay? Now let's search for the force, which are forces acting on this. So mg is acting this way, P, tension along a string, is acting this way away from the body, tension is this way. So now once again we have two forces, one is T, the other is mg is acting this way. So which force to resolve? Now we have to see, now first of all we see that is in which circle the body is moving. This body is moving in its circle. So do not disturb the forces which are along the radius. Do we have any force along the radius? No, I don't see any force along the radius. There are two forces, mg is here, T is here. This is moving in a horizontal circle. This is not moving in a vertical circle also. Please understand, this is not moving in a vertical circle like this. This is moving in a horizontal circle. So do not try to break mg as we have broken earlier. That is mg sin theta here, mg cos theta over here, something like this. Now we have to find the net force, that is the force towards the center of the circle. This is a horizontal circle. The component of mg, which is a purely, mg is acting purely along the y-axis. The component of this along x-axis will be 0. So there will not be component of any this thing of mg along the radius. If we see T, so if this is theta, so this is theta, so this is T cos theta, I break its component, and T sin theta. So that's why the components, that is T is broken into its components. One is T cos theta this way, the other is T sin theta. So when it is moving in a circle, horizontal circle, maintaining a same level, the body is moving at a same level. So it means that is this force has to be this force, because the body is neither going up nor coming down. It is not accelerating up or accelerating down along the y-axis. So net force along y-axis should be equal to 0. It means the upward forces, they should be equal to downward forces. So it means T cos theta should be equal to mg. Also, T sin theta should provide the centripetal force, that is mv square upon r. T sine theta, this is towards center and the body is moving in a circle. It requires a force mv square upon r. Who will meet this requirement? This requirement is going to be met by the force. There is only a single force, T sine theta this way. So T sine theta should be equal to mv square upon r. When you divide the two, so tan theta, m and m they cancel, v square upon rg, you get the answer. This is theta, v etc. if they are given, you can find the value and you can get the answer.